Hello friends, welcome to our Python threading tutorial for the absolute beginner. This tutorial is aimed at a person who is familiar with Python but want to learn more about the threading library. So here you will learn how to create a thread using the Python library. We will teach you how to create the thread, how to join different threads, and how to send data between the threads. For example, you can send data into the thread as an argument, or you can share the data between two threads. And we'll also teach you how to use a synchronization lock or a mutex so that you can coordinate the axis of a shared variable between two different threads. Now we'll also teach you how to set up an event and to exit from an infinite loop using an event. And finally, we will tell you how to implement a producer consumer pattern in Python. This is a very useful pattern which is used for sending data between a producer and a consumer thread. Now, all our code are available in the GitHub, and we'll be using the Python 3.12 version, the latest one. So we'll now go into our tutorial. If you like our tutorial, do like and share. If there is an issue with our tutorial, do comment it in our comment settings. I'll try to read it and answer it. So let's start our tutorial. Now, when we execute a executable file, for example, .exe file in Windows, the operating system will create something called as a process. Process is known as the running program. The operating system will allocate memory, stack pointer, and a stack for running this particular process. This is done by the operating system and may vary between operating systems. But in our case, we don't have to worry about that because we'll be using Python and we will not be delving deep into the internal processes. So every process will create a main thread. This is the main thread and this is the process. Now, some of the processes may create more than one thread. It depends upon the process. Now, when we are executing a simple program called as simplescript.py, this is a simple code. It will just print a hello to the command line. That's all. So we will use this particular command. This is a Windows system. It is similar to the Linux system. So we'll call the Python interpreter. Here it is CPython. Then we'll give the name of the file to be executed. So the CPython interpreter will take in the file. Then it will convert the file into bytecode, which will be interpreted by the CPython interpreter. So it will create a CPython process. Then it will create a thread, which is the main thread. And all processes will create this main thread. Then it will run the bytecode inside the main thread using the CPython interpreter. So there will be only one thread here because our program is quite simple. And after this is done, the program exits. Now here we will learn about multi-threading in a Python program. So remember the old script that only had one thread. We can spawn multiple threads using the threading library. So this is how it will look. We'll have a main thread that will create additional threads like thread 1, thread 2, and thread 3. This will be done by the threading module of the Python. So when we do this thing, we have access to the global variables. So all these threads will have access to global variables, which we can use it to share data between the threads. This process will be inside the CPython interpreter. Here we are using multi-threading. In the case of multi-processing, the system will create additional process that is different from this one. Here we'll be concentrating only on a single thread, a single process actually, not thread. We also have a website tutorial for this video. You can find that link in the description below. We have if you would like to read this, you can read it from our website. There is a link to the source codes also. They are in the GitHub repo. You can check it from here and you can download the code from there. This is the repo and these are the codes. They are numbered numerically. Just check it in that order, 1, 2, 3, 4, 5, like that. Now I'm using the standard Python interpreter. Here I'm using Python 3.12 on a Windows platform. You can download it from the official website, python.org. Now for coding purpose, I will be using sublime.txt. You can either use a notepad, sublime.txt, or any other IDE of your choosing. to demonstrate threading on Python. Here we'll be only creating a single thread, and it will not do anything, just for showing how it is done. The first thing we should do is to import the multi-threading module. So we had to use the import command, and threading, that is the name of the module. It is available in the standard Python distribution. So if you are using the standard C Python, it is already there. So you don't have to download anything else. Now we have to create a function. Let's call it do something. It doesn't do anything right now. We'll just write it like this. Colon, and we will put pass. We'll populate the function later. Right now we'll just put something placeholder for here. And now we'll create our thread. So first we'll call T1 equal to threading dot thread, capital T. Okay. Now we have to provide a target. When we are creating a thread, we should tell the thread that which function you should run. So we'll use the target keyword, target argument, target equal to name of the function. So it will do something. Now we have to start the function. For that, we'll use t1.start. Start is a method that comes with the module. So this is just start the code. It will create a thread. Now it is not going to do anything. So now it will call target equal to do something, and there is nothing in target. So we need to provide something. So we'll write print hello from thread. So it will now. So when we run this program, the thread T1, it will call the do something function here, and it will print the data that you can see from here. Now there are two threads in this program. The first one is the main thread. That is the thread that is doing all these things. And the other one would be the second thread. That will be thread T1. So the execution will look something like this. So this is the C Python process executing our threading program. So first it will call the main thread. That is the one that is doing all these things. So it will create a thread T1 equal to this one here. Then when we call the T1.start method, it will generate a separate thread that will execute concurrently. And in our case, it will just print something, and it will continue executing till the process exits. So both of these will execute concurrently, not parallelly, but to the user, it will appear that both of these things are executing at the same time. Now in the previous example, we created the thread T1 right here, and then we started the thread using T1.start in the next line. You can do it here itself by just using .start like this. So you don't have to do it here. So it will work similarly. This is one way to do it. Now here we have created only one thread. You can actually create multiple threads. I'll create another thread T2. So this will work similar to the other one. We'll create two threads T1 and T2, and we will start it right here itself instead of doing it on the separate statement. So this will print out two messages. All these threads have names. So you can get the name of a particular thread using the current underscore thread method. So we'll print it out. So this will be print. You have to give the namespace threading.current underscore thread. Now this is the main thread, so it will print out the name main thread. So this This is the name of the main thread. That is the thread that is going to create T1 and T2. So it's named as underscore main thread. So if you don't want this one, you can use the name property. So you can just put name here and it will show only the name. See, like this. You can also get the name of the other threads. Here we are creating two threads, T1 and T2. So you can go inside this one and you can put the same function. We're putting it inside def do something. So this will print the name of their threads. So I'll run this. So the program is running. The program has run. So here it started on the main thread. So this is the main thread. Then it created two threads, T1 and T2. And we are displaying the name of the thread from the thread function. So these are printed from the different one and they are called as thread1 and thread2. So this is how we can get the name of the thread. So here we are running the same function again and again. So you can also use, you can use two different threads to start two different functions. For example, I can create another thing like this one. We'll call it do something else. So we'll start it as thread T2. Like this. Now, due to the presence of the global interpreter lock, Python interpreter cannot run two threads at the same time. So it will just run it concurrently. It will run one for some time and the other for some time, like that. So if you need some performance improvement in computationally intensive problems, for example, you have to calculate a large number, which will use the CPU for a long time, then threading will not give you any significant speedups. But threading is really good if you want to use it for waiting, doing something different, like waiting for IO from a device like serial port or write into the disk file, like that. Then threading would provide significant speedup. Now you can create two functions, while one will write to the disk, while the other one will wait for the serial port. So in that case, both of them will be running concurrently, and there will be a significant speedup. Now this is the second thread. Here I am importing another module called time so that we can get some delay. So we'll be using the same function, def do something, and we are adding a couple of printf statement to state that it has entered the function. And we are also giving a small delay, which is called as time.sleep here. This is to simulate that some work is being done, because the main idea of a thread is to do some work. So we will create a time.sleep. So it will delay, it will remain here for 2 seconds, or it will block here for 2 seconds. You can change the delay by giving it another value like 4 or 5 or something like that. All the values are in seconds, so I will be putting it for 2 seconds. So now in the main thread, from here, we are starting the main thread and we are creating the thread T1. And we are providing the target, do something. So I'll run this code. And before that, when the main thread ends, we will display this particular printf statement. That is, it is the end of the main thread. That's it. So I will run this code right now. So press Control B. So the thread has started. And then as you can see that it has ended immediately right here. Then after that, the thread had ended. That is, the main thread ended, then the thread ended. So let's say the main thread is not waiting for the other thread to finish. So let me show you how this thing will work in a block diagram. Now this is the graphical representation of the program that we just ran. Here we have the main thread that is creating the thread T1. Now we'll create the thread T1 from here and we will start it from T1.start. After which it will create a thread T1 and it will execute concurrently. that is almost at the same time, parallel to the main thread. Now, once the start statement has run, the flow of control will go from start to end of main thread. At the same time, the thread T1 will print ended, and then it will go to sleep. So this will execute first, and then after 2 seconds, the thread T1 will print this particular message to the console. So here we can see that the main thread is not waiting for the thread T1 to finish. It is executing at its own rate, both of them. So sometimes we may need thread T1 to do something and pass the value to main thread. So we may need to wait for thread T1 to finish. So for that purpose, we have to use something called as the join method. So we have to start the thread from here. Then we should wait for the main thread. We should wait for the thread T1 to finish. So we can use the T1.join. So this will join it. So now only after the main thread T1 has completed, the main thread will exit. So I will run it again and you can see the difference. It will wait for 2 seconds for thread T1 to finish. After that, it has printed that it has done sleeping in the thread. Then only the end of the main thread has been printed. So I will show you this is the graphical representation of how the join method works. Here we are creating it a separate thread T1 using the start one. Then the execution will go to T1.join. This will prompt the main thread to wait for the thread T1, this one. So after 2 seconds, the thread T1 will come here and then it will print the output into the command line. Then only this statement will execute. That is because of the join function, because it is asking the main thread to wait for thread T1 to complete. Here we have a simple hypothetical program that will help to illustrate the use of the join statement. Here we have the main thread. The main thread will start 3 separate threads that will download a web page. All 3 of them will download any web page, and then it will create a single web page from all these 3 and then display it on the window. Now this is the hypothetical program. We will not be discussing the source code here. I just want to illustrate how the join method is used. So we will run the main thread here, and all these threads, thread 1, 2 and 3, will start to download the web page. And these 3 threads will take different amount of time depending upon the network traffic, etc. So once all these 3 threads are finished, then that main thread, all the data is sent to the main thread where this function will execute, and then it will create a single web page and then display the single web page. So that's where the join comes in. The join makes the main thread to wait till all these 3 threads are completed. Now let's say if there is no join, these threads will take different time, but at the same time the main thread will run directly into this particular function, provided this function is not there. Thread.join function is not there. Then we'll create an erroneous web page. These things are still downloading, so it won't have any data to work with. So this is where the join function comes in. It helps to join the threads so that we can successfully transfer the data from all these 3 threads and create a single web page. Now we will learn how to pass an argument to the threading function. So here we have the def do underscore something function, and it's going to print hello. So let's say we have to pass some number or some characters or list to the def do something. So we need a way to send that data. So that is done at this point using the threading.Thread function. So we have to use something called as the argument keyword. So you have to use args equal to, then you have to use brackets. So this, we have to provide your argument in this bracket. It's actually a tuple. So that will go to the def do something function. So here I'm not putting any variables, so I have to put one. So I'll put the variable a. So we have to put the variable, any variable like b, for example. Then we have to put a comma. Otherwise, it will create an error if I run this thing. So now you can be equal to 1 and you can print. So our argument is b equal to 1 and that will go to here. And from here, it will go to here and it will print the letter and I print the number 1. So I'll run this code. Yeah, so it has printed the letter 1. By changing here, you can give it some other value like 8. Now make sure that you have to use the comma here, otherwise you will create an error. You can also give them multiple variables. For example, you can give them a1. Then we have to give it. You can also send other things like list and other stuff. So if you want, you can give it a. Going to send a small list here. So we have B. B should be a list. Yeah, we forgot about the comma here. So this is how we pass the arguments to the threading function. Now in the previous example, we have passed data to the thread to do some work. Now the whole point of having a thread is that the thread should do some work and it should be able to return that value back to the main thread where it can be processed. So in this section, we will learn how to return values from a thread after some work has been done on it. Now there are two ways to do that. One is to extend the threading.Threading class and to store the data in the instance variable. And the second one is to use the global variables. So we will be using the global variables right now because it's the easiest one to do it. Here we have the memory diagram of the process. Now as you can see, there are multiple threads here, including the main thread. Now all these threads share the same memory space. So the global variables can be accessed by all the threads, including the main thread. Now you can pass data from thread 1 to main thread by storing it inside a global variable. Now you can also pass data between other threads by storing in the global variables. All the threads can access the global variable. Now that may cause problems due to race condition when two threads are accessing the same global variable. When we are doing that, we have to use some concurrency primitives like logs, semaphores, etc. Now here we will do a very simple example in which data is exchanged by using a global variable. Now we have the simple program here and we will be adding two numbers in a thread and the data will be given back to the main thread. So we have a global value called as global underscore sum, which is initialized to 0. That is here. Then we add the two numbers inside this particular function, which we will run inside a thread. So we are giving, arguments to the thread number 1 and number 2, this one. So we will first print out the initial value of the global sum, which we have already declared as 0. We will create the thread T1 and we'll pass the function as its argument. And we will also give two numbers 5 and 10 as its arguments. So they will be added and the sum is 15. And we will print it from here. The printing is happening inside the main thread. This is the printing one. So I'll run this thing. So you can see that the initial value is 0. And after the calculation, the sum is 15. 5 and 10, 15. This one. Now the calculation is done inside the thread here. And the value is, the sum is actually stored here. And in the end, the main thread accesses it from here and it prints it out. In this way, we are exchanging data from the thread to the main thread. Now we have to make sure that you use this global identifier here. Otherwise, the data will not be written into the global variable. For example, I will comment this thing out. Now it won't work. So you can see both the values are 0. So this is actually became a local variable. We have to use this particular line. You can also use other data structures like list, dictionaries, etc. to transfer data between the thread and the main thread. Sorry. Now here we'll be appending a list. So with two strings, one will be appended from the main thread and the other one will be appended from the thread function. Now first we create this global list which is empty. Then we append global list from the main thread. After that we create a thread T1 to which the target is declared as this particular function. That will be this one. So we'll create the thread and we'll start the thread. When we start the thread, here we will append the list from inside the thread. Now that value will be available right here. Now one thing you should remember that we are not passing the list as an argument to the function. It's because it's a global variable. Both the functions can access it without passing through the function. Both main thread and T1 can access it directly. Now you can also pass it. There is nothing wrong in that. You can give it. I think it's the more formal way to do that. So I will run the program right now. So it's showing that it is the first one is that it is appended in the main thread, and the second time it is appended in the thread. Now in the end we have two strings that are appended to the global list. In the last example, we learned how to share data between two threads using shared variables. Now in that case, two threads were accessing the shared variables. Now we need to make sure that the shared variables are only accessed by a single thread at a single time. If two threads try to access the same shared variable, it will result in race conditions, which will result in corruption of data or hanging of the program. So for that purpose, we should have some synchronization mechanisms which can be used to stop two threads from accessing the same variable. One such synchronization method is called as the lock. Now the lock is present inside the threading.Lock class, and we have to create this particular threading.Lock class in our program. Now the section of the code that contains the shared resources that is being assessed by the two threads is called as the critical section. Now threading.Lock protects these critical sections so that only one thread can access the code segment at one time. Lock can be in two states. One is called as locked or unlocked. So first the thread will acquire the lock using the method acquire, and then it will do the thing it has to do. For example, incrementing a variable or sharing some data. After that particular thing is done, it will release the lock. Before using the lock, you have to create a lock object using lock equal to threading.Lock. So then only you can call the acquire and release functions. And we are explicitly acquiring and releasing it. So you can also do it using context manager. So here, instead of doing that, you can just use with my lock before the critical section. So here we do not have to explicitly acquire and lock it. The system will release and acquire it depending upon the context. Now we will run a small program to illustrate the effects. Now this is the code we are going to run. It has a global variable called shared list, and this will be modified by two threads T1 and T2. Now we will append the characters A and B to the list one after the other. So the output would look something like this: AA and then BB like that. So if I run this program, it will work perfectly. So it will show it will append the list in this particular order. The A's will be appended first, followed by B's, like this. Now I'll remove the lock so that both threads can access the shared value at the same time without any control. So I'll tell you how the function works also. The name of the function is def update list A, which will update, write A to the list. And for that, it is using a for in range loop, and it will use the normal append A. Then it will sleep for a small time slice. Here it is 100 milliseconds. Same here also in update list underscore B, it will append the letter B, 10 numbers, and it will sleep for some time during each append. So this is how the code will work. And I have removed the lock here. So two threads can access the shared variable, and this is the shared variable, shared underscore list. So this is an empty list. So I'll run the code right now. So as you can see that at first A is appended, then B is appended, then A, B, like that. Now if you run it again, here we have the A, B, then we have an extra B here, and then A, B, AA, BB, AA, BB, like that. So every time when you run this thing, the way in which the letters are appended to the list is different. This is because there is no control in which the shared variable is accessed by the thread. This is the graphical representation of the program. This is the main Python thread. These are the thread T1 and T2 that is started by the main thread. Here we have the shared list variable. It is the global variable that both T1 and T2 has access to. Now we also have an operating system scheduler, which will decide which thread to run. Since we are starting T1, usually it is the first one to run, this one. So this will update the letter A to the shared list, this one. So we are doing that in the form of a loop. So we will append 10 A's to shared list. So first it will append the letter A, then it will go to sleep. Now when the thread T1 goes to sleep, the operating system scheduler will stop running the thread T1 as it is waiting for something due to the time.sleep function here. So it will decide to run another thread that is ready. So usually it will be thread T2, or if any other thread. For example, there are multiple programs running on the operating system. So if any of those threads are ready, it may or may not run it. So here let's assume that it runs the second thread T2. So the thread T2 also has a similar for loop, and it will append the letter B to the shared list. After that, it will go to sleep. Then the operating system scheduler will change it back to any other thread that is ready. Usually it will be A, or usually it will be B, because sometimes it is not available, or it depends upon the scheduling algorithm of the operating system. So this is how a shared list is working without any lock. We have no control how the letters are appended to the shared list right now. So you can see here, we are appending it A, B, A, B, A, B, like that. Now we have here you can see that it was appending A, B, then instead of A, it is appending B, because it depends upon the scheduling algorithm. Now we'll be using lock to stop it. So what we'll do is that we need to make sure that when you are appending the A, only this particular section would run. Even if the operating system decided to switch, this should always run. So for that, we will require what is known as a lock. So the lock has two methods. One is called as the acquire method, and the other one will be release method. So we will just uncomment these lines. So this is the lock.acquire. We'll also do that here also. This is the second function. Now we have allowed lock to work. Now what happens is that the code will come here, and it will acquire a lock. After that, no other thread will be allowed to access the this particular section. Always this will run first. So it will append the letter A, then it will go to sleep. Now, since this is under lock, and if the operating system decided to switch um, and decided to run the other one, this one, they will not be allowed to access the shared variable because we are holding the lock. We have not released it. So I will show you the graphical representation. So this is the same thing. Now we are using the lock. So let's assume that the shared list is locked by thread T1. So once we have acquired the lock, we will write the letter A to the shared list here. Then we will go to sleep. Now once we go to sleep, the operating system scheduler will decide to run another thread. Let's say it's B, thread T2 B. Now when it tried to access the shared list, it says that this shared list is locked, you cannot have it. So it doesn't do anything. So the operating system will decided to switch to another thread. It could be this one, or it could be any other thing. Then let's say it switches back to this one. So it will come here. It will append the next A because it is a loop. Then it will go back to sleep. Then the OS scheduler will switch again. And here, due to the lock, it won't be able to access the shared list. So it will go to sleep again because it does not have anything to do. So the OS scheduler will decide to put it to sleep. Then it will switch back again and it will run again and again like that. So once the lock is released only, the thread T2 can access this one. So since thread T2 has this lock and release mechanism is there, once the second thread start, it also has a lock acquire and a lock release function. So only the letters B will be updated here. I mean, this won't be running, but if there is another thread trying to access the shared variable, they won't be able to access. Same here. So this is how a lock works. Now here we are going to learn about another synchronization primitive called as the event. Now events can be used to signal other thread that a certain event has happened and you should do something regarding that event. Now you can create the event by using the threading.Event class, this one. Now it is kind of like a boolean. It can either be set or cleared. Now there are two methods, mainly the set and the clear method. This is used to set the event and clear is used to reset the event. Now the thread can also wait for some time till an event has happened. Now you can create the event using my event equal to threading.Event. This will create a new event, and by default it will be unset. So you have to explicitly set like this one to make this thing true. You can also check the status of the event by using the isSet method, whether the event is set or not. It is set, it will return true, or else it will be false. Now we will check it using the Python interpreter. First we import the threading library because event is inside the threading module. So we do the import one. Now we create a new event. We will call it my event. Threading.Event. Capital E. We have created the event. Now you can check whether the status of the event. So it will be not set right now. As you can see, it's unset. Now you can set the event by using the set primitive, set method. So I'm going to set it, call the set method. See, the threading event is set now. You can check this event whether anything is set or not in a different thread. So that can be used to change the behavior of the thread depending upon certain condition has been met or not. So you can, for that you can use the isSet method dot is underscore set. We have set the method first. So this will return as true. Now let's clear the method. So this will make the method false. So if we run it, reset, it will give you false. This is the basics of an event. Now we can use that in our programs, which I will show you next. For example, you can make a thread wait for something. You can escape from an infinite loop using this. So we'll go to the code now. This is the graphical representation of the program. In the main thread, we will create a thread T1. It will be this one. And we will create an event, my_event, using threading.Event. Now we will start the thread T1. And then there is one function called as my_event.wait. Now this will check, this will stay in this particular place until an event is set. For example, my event has to be set. Then only this will exit from here and move towards the other section of the code, which is written below this one. Okay. So otherwise it will just stay here itself. So if we set the event from the main thread, this will make the wait function unblock, and it will allow the code below this one to execute. This is useful when we have to do something. For example, the function T is waiting for something that has to be completed in the main thread. For example, it has to populate an array or something in the main thread, or main thread has to get something from outside. So it's taking some time, and that thing has to be given to the thread T1. So only after the data is available, T function underscore T should execute. So we can use this setup where when the data is available on main thread, we will set the my event underscore set, and then this thing will operate. I mean, the event.wait will unblock and the code will execute after the event. Otherwise, it will just wait here till the event is set. So this is the code. Here is the function T. So we'll create the my event here using the threading.Event. We'll start the thread from here. Then we'll set the my event. We'll set the my event from the main thread only after 5 seconds. So what will happen is that thread T1 will create and will come here and will block here just like this. It will set the my event.wait will make the thread T1 block. We have put the my event.wait timeout equal to 0 here. This would make it wait. We also have a timeout, so it won't wait forever. I'll tell you why it is required. So after 5 seconds, this event will be set and this will unblock and this statement will be executed. So I'll run this thing. So we have under T1 and the other one will be set in 5 seconds. So the event is set. So the line inside the thread T1 has been printed out. Now what we'll do is that we will never set the event. Like we will comment this line out. So the event will be never set and the thread T1 will be left waiting forever. So to prevent that, I have given you a timeout, just 10 seconds. So if I run this thing, the thread T1 will run whether the event happens or not after 10 seconds. So it will wait for 5 seconds, but nothing is there. So after 10 seconds, due to timeout, this will come. If there is no timeout, this will stay there for all eternity. This thing will never come because there is no timeout. Here we will demonstrate how to exit from an infinite loop using the threading.Event. So for that, we will be using the isSet method. whether my event is set or not. So we have a infinite loop function, this one, which will print a read from serial port. It is not reading from anything. It will just print that, and it will wait for 1 second. Then this is an infinite loop, while loop. Then it will go again and again like that. Once it has exited from the while loop, it will print this one. So here inside the while loop, there is a check. If my event is set, it will break from the while loop, it will exit from here, and this thing will run. So we'll do the same thing here. We'll create a my event. This is not required actually. So clearly not required actually. Now we'll create the thread. We'll start the thread and we'll wait for 5 seconds. So here the my event dots will be set after 5 seconds. So once it is set, they will exit from here, and this particular line will run. So I'll run this on. I'll run it again actually. So we have started loop and it started reading from the serial port. After 5 seconds, the main loop set the event here. So which caused this one. If my event dot is set is true, then break from the, so it exited from the loop. And now it then printed this one. If you do not set this thing, it will keep on running like this. So this will never come, even though event set it. That is just the print statement, because we are blocking this one. So this will keep on going. In this section, we will learn how to implement a producer-consumer pattern using Python. Now, producer-consumer pattern is a classic synchronization problem. Now, it includes a producer thread, this one, and a consumer thread, this one. Now, the producer will produce certain data continuously, and the consumer will consume that particular data. Now, the producer will send that data through a shared buffer, and the consumer will read that data from the shared buffer. Shared buffer is usually a data structure like queue. So it will be usually a first in, first out. The queue can also be a last in, first out, LIFO queue also. So for implementing that, we have to use a queue. Now this paradigm, the producer consumer pattern, happens a lot in programming. For example, we will have a producer thread that may be a serial port listening program or a network port which is listening to some data. So once the data starts to come, they will send that data to a consumer thread, which will either process the data or write into a file or something like that. So this can be useful for building a large variety of program. Different methods are available. Different patterns are available. Here we'll be using one producer and one consumer. There can be other iterations like multiple producer, multiple consumers, or multiple producers, single consumers, or multiple consumers and single producer. All the permutations and combinations are available. So we'll go to the queue first one. We need to use a queue for this one. It is a first in, first out data structure. Now for creating the shared buffer, we need a data structure called as a queue. Queue here is a first in, first out data structure. Now it is present inside the module queue. So we have to import that module. It is part of the standard library, so you can use that. And the queue start with the capital letter Q. Now there are other types of queues available in this module. For example, LIFO queue is also there, which is a last in, first out queue. And we also have a priority queue. So the data that is sent inside is arranged depending upon the priority. So we will not be using any of these two. we'll be using the first in first out data structure. That means that whatever data you put inside the queue, when you take it out, that data comes first. So first data that is put inside comes out first, just like in a normal queue. So the other thing is that this is also thread safe. So you can use it in a multi-threaded setup. So I will use the code now. First we have to import the library. Then we'll create a queue. It's called queue. So queue, you use the capital Q here. That is the first in first out queue. Create that queue. Now queue has some methods to put data into one. So the method is called as put. So we can put some data into this one. Let's put 1. Then we'll put 2. Then we'll put 3. So now the queue contains 3 numbers. Now we are going to take that numbers out, so that you can use it by the get method. So you can just put queue.get. So this is a first in first out data structure. So we put the number 1 as the first entry. So when you run the .get, you will get the number 1 as the other one. Then you can get the, so if you run it again, you will get 2. And if you run it again, you'll get 3. So this is how a queue data structure works. Now we will create a small program that will send data from a producer thread to a consumer thread. So we'll be starting this is the main thread, and we'll be starting 2 threads, and each are called as a producer and a consumer. Now we have a queue data structure which is named as a shared buffer. So what the producer thread does that is that it will put some data, for example 1 in a loop. So the first one will be put 1, and second one will be 2, like that. 10 numbers will be put inside this one. And then on the consumer side, we will take that data one by one. So whatever data is put in this order, you can take it from this one. So this is how it will work. I'll run the code now. This is the code for this one. We have created 2 functions. One is called as the producer, and the other one is called as the consumer. And we have created a queue called shared buffer. And then we have created 2 threads, T1 and T2. And we'll start both of them here. Now inside the producer, we will produce some data. For that, we will use a for loop. So we will run it 10 times. So every time we run, we put some number into this one. So it will be 1. Then we will put this to sleep. So once the loop is finished, we will send a null value. This is like a termination character, or a sentinel value. This means that the consumer thread can understand that no more data is going to come from the producer side. That's why we will be sending the none value. So we'll put it inside the thread. So on the consumer side, we will have an infinite loop. So this is the infinite loop while true, and we'll get the data one by one from the shared buffer, and it will store the data in this particular variable. And here whether it will check whether the received data is equal to none. If it is none, it means that no more data is coming, so it will break from here. So if it is not none, it will print the received data on the command line. So I'll run it. So we are printing it from the consumer thread, this one. I haven't written any print statement here because I just want to make sure, I just want to show the logic only. If you want, you can add the print statements. So this is how you implement a producer. consumer. Hope you enjoyed our tutorial. All the codes are in the GitHub. The link is in the description. If you like our tutorial, do like and subscribe. If you have any doubts, do put it in the comment section. I will read it and will try to answer it if possible. So thank you for listening to our small tutorial.